All right, so now we want to talk about solving systems of equations by graphing. And we mentioned that we're looking for, when we solve a system of equations, we're looking for the point where they're intersecting. So I have these two equations, and I want to find where is their point of intersection. That's what we mean by solving a system of equations. We're looking for the point where they intersect. So I check first, and I notice that they have different slopes. And that's important because I don't want to waste my time if it's not going to have an answer. And so they do have different slopes, so I know they're going to intersect. So I need to remember all my rules about graphing lines. This is going to be my slope, and this is going to be my y-intercept. What you also have to realize is I can't graph both of these at the same time. I'm graphing two separate lines. So I want to make sure that I do one at a time. So this one is going to have a y-intercept of -1. That's right here. And then I've got a slope of 3/1. So it's going to go up 3 and right 1. So starting at my y-intercept, I go up 3, right 1. Up 3, right 1. Ran out of room. I can go backwards and go the other direction. Fit as many of them on here as I can. And that gives me my line. For this first one, I did it in red. Now for the second one, here's my slope, -2/1. So I'm going to be going down 2/1. And my y-intercept is going to be at +9. So let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. That ran off my graph a little bit, but there's my y-intercept. My slope is -2/1. So I'm going to go down 2/1. Down 2/1, down 2/1, down 2/1, and I just keep going till I ran out of room on my graph paper, and that is my two lines. So notice, I went through all that work for one main reason. I'm only interested in one point, and that is the point where they intersect. The graph is not my answer. The graph is not my solution. The graph is my tool that I am using to find my solution. So my answer is actually at this point. The answer, the solution to a system of equations, should be a point. And this point is 1, 2. So 2, 1, 2, 3, 4, 5. So the point 2, 5 is the solution to this system of equations. Now, if you are doing a system of equations and they turn out to be parallel, you would know right away because they would have the same slope, but they would have different y-intercepts. So I wouldn't even bother to graph them because once I notice they have the same slope, I know I'm not going to get an intersecting point. When they have the same slope, you just have to look at their y-intercepts, and if they're the same y-intercept, then they're the exact same line. They have infinite solutions. If they have different y-intercepts, then that means that they're just parallel lines and they're never going to intersect and there's no solution. Now, we can also have systems of inequalities. So I've got y is less than or equal to 2x minus 3, and y is greater than -1/3 x plus 2. All right? So this is a system of linear inequalities because instead of an equal sign, they have the less than and greater than sign. And it is very important to note that to solve a system of inequalities, the graph is your answer. Because it's not going to just be one point where they intersect. It's going to be at many points where they intersect. When we graph an inequality, if you remember when we graph an inequality, that means that we're going to have shaded stuff. We have dotted lines and dashed, or solid lines and dashed lines, and we've got to remember, you know, which way to shade. Do we shade up or do we shade down? And so we want to remember those things. And we're going to review those real quick to make sure that we can graph a system of inequalities so that we can find our solution. Because to get a solution, it's still where they intersect. It's just that we're looking for where two shaded regions intersect, and that's a whole lot of points. So things that I need to make sure everybody remembers about graphing inequalities. Graphing the line is exactly the same, and nothing changes. So this is still my slope. This is still my y-intercept, It's still rise over run, so I'm going to go up 2 and to the right 1. That is all exactly the same. Finding it on the graph is exactly the same. So I'm going to go 1, 2, here's a -3. There's my y-intercept. And then my slope is up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, and I just keep going until I run out of room. Down 2 back, so I go in the other direction. So that part is exactly the same. Nothing changes. What changes is when we're drawing our line. Things that you want to remember. When it is equal to, you use a solid line, just like we used the closed-in circle when we were doing it on number lines. When it is not equal to, we use a dashed line when we're drawing our line. So in this case, it was equal to. So that means that when I draw my line, I'm going to use a solid line. All right? The other thing we need to remember is that it's not just the points on this line that work, but y is less than all of the points on this line. So that means that not just the points on the line work, but the points below the line work as well. So I have to shade in below the line. So I've got a solid line, and then all of these points down here underneath would work for this equation, because if I plug in x, it's going to give me some y that this is greater than, and that this all becomes true statements. Things that you want to remember: when it is greater than or equal to, you shade above the line. Greater than is above. And if it's less than or equal to, you shade below. All right? Now, let's graph this one. Let's do a different color for it. So this is going to be my y-intercept. And then my slope is going to be down 1 and right 3. So I've got a y-intercept of 2. I go down 1 and right 3, down 1 and right 3. I can go back the other direction. All right? That's my y-intercept and my slope. It is not equal to. So that means I need to use a dashed line. So it's not going to be a solid line. It's going to be a dashed line. So I used a dashed line. And it was greater than, so greater than is going to be shaded above. So I'm going to shade above this line. Now, again, just like when we were doing an equation instead of an inequality, we were looking for the point of intersection. And what you want to realize with these graphs is that the point of intersection is where their shaded areas overlap each other. So the part that's just pink is not going to work. The part that is just green is not going to work. But the actual answer is going to be this shaded region over here where it is pink and green. So this is the solution to the system of inequalities. And that is how we solve by graphing.